Hello, this is Mr. Stansbury. I'm going to take you through the notes on outliers. At the end of this, you should be able to say that I can test data for outliers. Okay, so first things first, let's remember what an outlier is. An outlier is a data value that is either much larger or much smaller than the general body of data. Okay, it's a piece of data that really kind of throws off the rest of the statistical analysis for the rest of the data. Okay. So here's how we test for outliers. To find the upper boundary, so basically, like, let's say we have a bunch of data pieces here, and then we're going to say, like, right here is the upper boundary, and say right there is the lower boundary. Anything that's above that would be an outlier, and anything below that would be an outlier. So to figure out the upper boundary, you take quartile 3, and then what you do is you add 1.5 times the inner quartile range. And for the lower boundary, we take quartile 1 and then we subtract 1.5 times the inner quartile range. Okay? Any data that is above the upper boundary or below the lower boundary is considered an outlier. Outliers are marked as an asterisk on a box plot. So they're still included, but you just mark them as little asterisks. And then it is possible to have more than one outlier on either end of your data. Okay, so let's do this. Let's take a look at an example that will help us better understand all this here. So, example 9. Test the following data on the number of people who bought the remote buddy for outliers. Hence, make a box plot. So basically, we're going to just organize all the data, make a box plot, and then from there, we should be able to figure out our outliers. Okay, so you know what? Again, this is not a whole bunch of data, so I'm just going to do this one by hand. Again, you can do this with the graphing calculator, but it's not too much to do by hand, so let's just try that. Okay, so here's all of our data organized from least to greatest. Okay, went through and counted, and there are 14 pieces of data, so that means, let's see, we're going to want to find our 5-number summary first, right? So we're going to want to find the minimum, quartile 1, median, quartile 3, and our maximum, right? So we know the minimum right now is 6, maximum is 23, and then let's see, median. So we're going to have 1, 2, 3, 4, 5, 6, 7. So right here is going to be the median. So that's the average of 14 and 15, so that's 14 and a half. So there's 7 pieces of data here, so that means there's going to be 3 below, 3 above. So it's going to be that number right in between those 3 pieces of data. So that means quartile 1 is 12. Same thing over here, 1, 2, 3, 4, and then 1, 2, 3 there. So then our quartile 3 is 17. Okay. So we've got our 5-number summary. So what we're going to want to do is it does ask us to make a box plot, and then we're going to calculate for outliers. But before we do that, let's do a quick little comedy break. We haven't done one of these for a little bit.
You got that one.
All right. Let's see. So let's make our box and whisker plot. Okay, so lowest number is 6, highest number is 23. So let's make ourselves a nice long line here, and let's do, I'm going to go by 2, so like say 6, 8, 10, 12, 14, 16, 18, 20, 22, and then that's be 23, 24. That should be all we need for that, right? Okay, so get rid of the rest of that. You can leave it on there too, no big deal. Okay, and then now let's put our 5-number summary on there. So here's our minimum at 6, quartile 1 is at 12, median is at, that's 15, there's 14 and a half about right here. Quartile 3 is at 17, and then our max is at 23. Okay, now before I go through and make the whole box and whisker plot, we really probably should calculate for outliers first. Okay, because then if we have outliers, we need to take those out and then recalculate, right? So let's see, with this, our inner quartile range. So if you remember our formula, it is to take the quartile 3 and quartile 1 and then add and subtract. So let's just start off by finding the inner quartile range. So that is 17, the IQR is 17 minus 12. So that is 5. Okay, so then to find our range, we're going to take that 5. Let's see, we're going to take that 5 and we're going to multiply it by 1.5, which is 7.5. So to test for outliers, for the upper quartile, we take 17 and then we add the 7.5. So that's going to be what, 24 and a half. And then for the lower quartile, we start with the lower outliers, we start with the lower quartile, 12, and then we subtract 7.5. And that gives us, let's see, 12 minus 7.5 is 5.5, right? Okay, so anything that's above 24 and a half, which that one is 23, so that one's okay. Anything that would be bigger than that would be considered an outlier, and anything that's 5.5 or below, this one's 6, so that one's still okay. 5.5 and below would be considered an outlier too. So neither one of our minimum or our maximum are outliers. So we just now can make our box and whisker plot, and then we will be all done and good to go. All right, so we just make here's our box for the middle part, and we make the box just because it makes it a little bit easier to recognize numbers quicker. Okay. So we have all this. Again, especially since we went by 2s down here, I would really highly suggest writing our values up here so that there's no question at all as to what they are. So that is supposed to be 12, that is 14 and a half, that's 17, and that's 23. Okay, so we went through, we organized our data, we found our 5-number summary, and we then calculated for outliers. So again, as long as it's not above 24 and a half or below 5 and a half, which none of the data was, then we officially have no outliers. But let's just, for kicks and giggles, say that there was 27 out here as well. Okay, then that means that out here at, like, say 27, we would have an asterisk as the outlier, because that would have been above our outlier data range there. Okay. All right, that's all there is for outliers. If you have any further questions, please feel free to ask in class. Thanks.